So here the next question is Laplace transform of e raised to minus at cos h ohm 0 t into u of t. Okay, so now we know that the Laplace transform of cos h ohm 0 t into u of t, right, is equal to s by s square minus ohm 0 square. Okay, so here if I am going to apply the frequency shifting theory over here, we know that the Laplace transform of e raised to minus at x of t is equal to x of s plus a. Okay, so in other words, the Laplace transform here x of t is equal to cos h ohm 0 t into u of t. Okay, so this is your x of s, right? So in other words, the Laplace transform of e raised to minus at into cos h ohm 0 t into u of t is equal to, replace every s that you see here with s plus a, because this function becomes an s plus a function. So this s becomes s plus a by this s square becomes s plus a the whole square minus ohm 0 square. Okay, now for the last question, finding the Laplace transform of e raised to minus at sin h ohm 0 t into u of t. Okay, here also as usual we know that the Laplace transform of sin h ohm 0 t into u of t is equal to ohm 0 by s square minus ohm 0 square. Okay, so now by applying frequency shifting theorem to this equation, we know that the Laplace transform of e raised to minus at x of t is equal to x of s plus a, right? And here x of t is nothing but sin h ohm 0 t into u of t, right? So now if I apply frequency shifting, this is my x of s, so now this x of s becomes x of s plus a, or in other words the Laplace transform of e raised to minus at into sin h ohm 0 t into u of t will then become ohm 0 by, so this will become a function of s plus a, so replace every s with s plus a. So this s over here, s is already over here, so this becomes s of s plus a, so s plus a the whole square minus ohm 0 square. Okay, you can also use this directly as a one formula, but even if you can't remember this also, it's okay. Like I said, all you need to do is simply apply frequency shifting theorem to your original formulas, the formulas that you have studied earlier. Okay, now let's do another problem. Okay, let's do another problem using frequency shifting theorem. Here in this case the question is, find the Laplace transform of 4 into e raised to minus 2t cos 5t minus 3 into e raised to minus 2t. Is it 2t, or I think I'll change the question, make it 3t. We don't need the same value. Okay, otherwise the question become more easy. So here in 3 into e raised to minus 3t sin 5t into u of t. Okay, that's the question. This can also be written as Okay, so it's better if I put my u of t inside both of these things. So I'm going to put u of t inside the bracket. So this will become 4 into e raised to minus 2t cos 5t into u of t minus 3 into e raised to minus 3t into sine 5t into u of t. Okay, so the Laplace transform of x of t is nothing but the Laplace transform of the first term and the Laplace transform of the second term. Okay, or in other words, this is equal to the Laplace transform of the first term. 4 is a constant, so I can take it outside. 4 into Laplace transform of e raised to minus 2t cos 5t into u of t minus the Laplace transform of the second term, that is 3 into the Laplace transform of e raised to minus 3t into sine 5t into u of t. Okay, so now we're going to find the Laplace transform of the first term. Alright, so we know that the Laplace transform of cos ohm 0 t is equal to s by s square plus ohm 0 square. Okay, so here ohm 0 is equal to 5, right? Ohm 0 is equal to 5. So that means here ohm 0 is equal to 5. So therefore Laplace transform of cos 5t is equal to s by s square plus 25. Okay, so into u of t. Okay, into u of t, this is a unilateral Laplace transform, so it is, you have to multiply with u of t. Okay, into u of t in both. Okay, so now in that case we know that the Laplace transform of, okay, we can also find the Laplace transform of this also in B. So you can apply the frequency shifting into both terms commonly. You can resolve it however you want. Okay, so here I can also say that the Laplace transform of sine ohm 0 t is equal to ohm 0 by s square plus ohm 0 square. Here also ohm 0 is equal to 5, so that means this will become Laplace transform of sine 5t is equal to 5 by s square plus 25. Okay, 5 by s square plus 25. So now I found into u of t. Okay, so now I have found the Laplace transform of cos 5t into u of t and Laplace transform of sin 5t into u of t. So now I am going to apply the frequency shifting theorem in both the case. Okay, so that means on applying the frequency shifting theorem, we know that by applying frequency shifting theorem, the Laplace transform of e raised to minus 2t cos 5t into u of t is nothing but replacing every s with s plus 2. So here there is s and here is also s. So this will become s plus 2 by s plus 2 the whole square plus 25. Okay, this is the Laplace transform of the first term. Okay, and the Laplace transform of the second term is given by the Laplace transform is e raised to minus 3t sine 5t into u of t is nothing but, this is the Laplace transform, so replace every s with s plus 3. Here e raised to minus 3t, so replace s with s plus 3. So and here and also here ohm 0 is 5. Okay, ohm 0 is 5, so it is 5 by s plus 3 the whole square plus 25. Okay, so therefore the Laplace transform of x of t is equal to 4 into Laplace transform of the first term, that is s plus 2 by s plus 2 the whole square plus 25 minus 3 into the Laplace transform of the second term, that is 3 into 5 by s plus 3 the whole square plus 25. Okay, this is your final answer.